Hello, everyone, and welcome to the much anticipated award ceremony for the November 2023 NetBrain Automation Hackathon. I'm Jeff Nataro, your Director of Global Services Engineering, and alongside me today, I've brought two of my fellow brothers in automation that many of you may already know. First, we have Christian Prower, one of our lead network automation architects, and Rami Atwe, our Director of Global Support Engineering. NetBrain would like to extend our thanks to everyone that was able to make the extra effort to come out and attend one of our in-person power user training events this year. Through these face-to-face trainings, our instructors were able to see firsthand the passion that all of you have for not only networking in general, but network automation as well. And most importantly, you provided us a very captive audience ready to learn. Now, as one of the first big announcements of this awards ceremony, I'm happy to let everyone know that due to the runaway success of these in-person power user training events, our automation experts will return again in 2024. We're already planning a number of all-new training locations while revisiting some of our old favorites for another exciting year of bringing the best in no-code automation directly to your front door. Be sure to keep a close eye on our website and your email inboxes for announcements as the year draws to a close. Now, I'd like to officially start our award ceremony by extending our thanks and congratulations to everyone that participated in our November hackathon. Automation innovation is truly a global effort. We had so many submissions from engineers from all around the globe, and we are thoroughly impressed with the cool stuff you've been able to build. It's truly been a celebration of the no-code automation innovations that NetBrain has included in our latest releases specifically for engineers such as yourselves. I'd also like to thank our judges who worked tirelessly sifting through all of the submissions. It took this team a lot of time and energy to review and discuss all of the submissions for technique, quality, and accuracy to be able to identify those that will ultimately be crowned November Automation Champions. All right. Now, before we announce the winners, Christian, Rami, and I would like to take this opportunity to review and showcase the solutions to our November 2023 Automation Hackathon. In this hack, we challenged all of you to create solutions using no-code automation for 4 unique and different real-world scenarios in the areas of map and design, auto diagnosis, network assessment, and finally, safe change. To get us started, Christian's going to walk us through our first automation challenge, map and design.
Well, thank you, Jeff, for that great introduction. And now, without further ado, let's dive into Challenge 1, Map and Design Solution Walkthrough. The goal of this challenge was to provide engineers with the capability of verifying and validating OSPF infrastructure design, operational state, and ultimately be able to compare it to the actual desired operational state. As you will be able to see in just a few when we dive into the platform, the idea is for any OSPF-enabled router that we can pull into any map to be able to answer the questions we have in order to achieve the before-mentioned goals. This is, for example, pulling data from any OSPF speaker device, such as OSPF neighbors and their status, OSPF global and interface configuration, OSPF routes, and so on. We will use this data to perform diagnosis and ultimately be able to achieve what we are proposing. Now, in order to achieve this, we are going to be following the think like an automation architect way of thinking, which will enable us to decode and baseline OSPF design on all relevant Cisco devices within the NetBrain domain. And then for any Cisco devices that we can get into a map at any point in time, enable the automation capability to illustrate the OSPF design, changes of the OSPF status if any, and achieve ultimate OSPF domain documentation. The tasks that we proposed in order to get this automation developed is to display the global configuration for OSPF in a map node format pointing to any of the OSPF devices at the time. Display the OSPF interface configuration in a table format, creating a hyperlink underneath the device so we can access this data should we need it. Display the OSPF neighbors and statuses in a similar hyperlink format tabulated underneath the device, for which we're going to be using the show IP OSPF neighbor command to retrieve the dataset. Then display the OSPF route count on a map underneath the device as well, following a similar format to the previous items, for which we're going to be using the show IP route summary command to retrieve the dataset needed for this. Highlight the device changes, if any, for any of the above mentioned items, meaning if the OSPF title changes, we want to know about it and we want the device to highlight. If there are changes on the OSPF routes and so on, we do also want to highlight the device for that. We will be enhancing the automation for the OSPF by having NetBrain to draw OSPF neighbors associated to the device that we're executing the automation on, also to be included in the map. And then ultimately, for this to work properly, we need to replicate the seed automation that we're going to be creating to all other OSPF speaker devices, so we can enable auto intent and store it under a specific profile for users to consume later on for any OSPF devices that can show up in a specific map. Now, in order to fulfill the full cycle of automation, what we need to do is enable automatic baseline updates on a frequently basis, which we're going to be picking a daily frequency at 6 p.m. Eastern to get this done. Last but not least, we're going to be moving into the platform and testing this automation for any device that has OSPF enabled on it. Now, there are 3 milestones that we will need to take into account in order to achieve this. And this is properly building the seed automation, in this case, the prototype automation or the prototype intent that we will need to achieve this. Once the prototype is ready, replicate this intent to the rest of the OSPF speaker devices so we can apply it to any OSPF device that can show in a map at any point in time. And last but not least, decide the type of output that we will use in order for users to consume the automation that we're producing. This is sending emails to a specific distribution list or users, printing the intent results into a dashboard, or enabling auto intent in this particular case in order for users to be able to use intents in the map every time that OSPF speaker device appears and in there. Now, without further ado, let's go ahead and jump into the platform in order to see how this works. All right, so let's dive into the Challenge 1 Map and Design Solution Showcase. And for this, we're going to pull our very first OSPF speaker router into a map. This is going to be DC WAN router 1. We're going to map this device. And because of the output that we choose was auto intent, in order for any engineer to be able to consume this automation, we're going to navigate and find the intent that we have created for this. So let's go to the intent menu, and inside of auto intent, we'll find the profile that we use to store this auto intent. And we're going to go ahead and execute this auto intent to our target device right here. So the first thing that we're going to do is we're going to get notified by NetBrain saying that product of this automation that we just executed, there are multiple devices besides the one that we targeted that are found and are going to be added to the map. And because that action is going to modify the original map that we created, NetBrain is asking us if we want to do this. Now, you may not want to do this for other use cases, but for this particular one, we do need that, and we're going to go ahead and say yes. Once that's completed, you can see that the exact same items that we were requested by the actual tasks are already completed. What this is the ability to post on the map the OSPF global configuration of the target device, as well as the OSPF neighbor table with a hyperlink that is clickable in order for us to access the information just like we wanted, as well as the OSPF interface configuration and so on, as well for us to be able to click it. The same thing is the OSPF route changes just like we wanted, the neighbor configuration and the neighbor, the OSPF configuration and the neighbor statuses for any possible changes. And because none of that is happening, we are being told by NetBrain that everything is just normal and fine. Last but not least, for every neighbor that was being displayed on the neighbor table, we wanted NetBrain to go ahead and map those devices as well, along with the seed device. And as you can see, very powerful. And to prove that this has been successfully replicated and that it should be able to run on any other OSPF speaker device within the NetBrain domain, we're going to pull a second device into the map that is also an OSPF speaker. In this particular case, HQP WAN router 1, which you can automatically see from the name that they belong to different sites, right? This is data center 1, this is HQP site right here, and we're going to execute the exact same intent that we did for our previous router 1. The first thing we're going to do is we're going to refresh to incorporate this device into the auto intent feature. We're going to deselect our original router and we're going to incorporate HQP router 1 here, and we're going to recreate the auto intent and we're going to re-execute this. Now we should see the exact same notification to let us know that the map is yet going to be modified once again, and we're going to go ahead and say yes because we also want to display those extra devices. So there you have it. From HQP WAN router 1's perspective, here is its global OSPF configuration. So we have two different sites already mapped with OSPF. The OSPF neighbor tables for HQP router 1, which you can see again, we have different type of neighbors right here that are part of the neighbor table. And as you can see, we are smart enough to also map whatever devices are running OSPF that are neighboring with our router 1, regardless of the platform or the type. Same type of information right here. We're doing the exact same level of verifications, again, because this is a replica of the automation created for our initial router 1. Very powerful, isn't it? Now, how do we get to this point? Well, if you remember from this slide deck before, we had a few milestones that we wanted to achieve. Now, let me navigate back to my original map right here, clean up a little bit. And then the point here is that this is the map that I used to create original automation and to test it. So if I actually go here, and the reason why I preserve this is because we use the quick intent feature in order to create this automation. The first step, if you remember again from the milestones that we mentioned before, the first step was to create the seed automation or the product automation. That encompasses different sets of steps. The first one is to pick the right target device, which we did. We picked an OSPF speaker device and we put it into a map. We came to the intent menu, quick intent, and we started collecting the data sets required to execute this automation that we just showcased. Now, the first step, as you can see, and then again, this is laid out in a way that you can't get lost on the series of steps that you have to follow. The first one, no matter what, is data collection. Data collection is nothing else than pulling either configuration or the output of a CLI command at the time, like we did here for show IP route summary, as well as the show IP route summary, the show IP OSPF neighbors, and the device configuration in order for us to take the data required in order to get this automation going. Now from here you can see that we parse the device configuration, we parse the OSPF configuration out of the OSPF enabled interfaces, as well as captured the actual OSPF global configuration. I'll showcase you the parsing in just a second. The same thing we did for the output commands, the command outputs, the show IP route summary and the show IP OSPF neighbors. So first and foremost, we need to capture the data sets that we need. and then we need to parse them out for us to be able to retain the values that we're going to use to determine if something change is different or not from now to either the previous capture or the baselining values that we're going to be setting. Now, let me show you the edit parser right here. And then you can see that this is what we did. We did collect the output of the show IP OSPF neighbors, and then we did an add table right here in order to build this parser. On the very same way, we did the same for the show IP route summary. And for this one, we went on a single variable basis. Remember that this can be done in this particular case because there's only one OSPF instance. Should you have a second one or a third one, one of the things that you will want to consider is paragraphs, so you can capture the exact same data for every iteration that you may have. Last but not least, what we did is we saved the map for us to be able to then go ahead and save this as a map intent, which in the end is what it's allowing us now to go ahead and go back to this so I can showcase how this has built on the first place. Now, because this is already a map intent, and you can see that the map that I'm using right now is embedded with this intent, I can go to the map intent and actually showcase the final result. Let's go ahead and go into edit mode. And then you can see we have the three data sets that we decided to collect: configuration, the show IP OSPF neighbor, and the show IP route summary. And then for each and every one of them, we set separate diagnosis. The first one is from the configuration. We wanted to make sure if there were changes to the configuration, whether local or in the interfaces. So in order to make sure that that is not happening, we are asking NetBrain via intent to verify if the current configuration matches or doesn't the baseline value, which is the one that has been established at the moment of the data capture for the first time. When that is the case, we want to get notified, and if everything is okay and matches, we also want to be notified that everything is okay. In addition to that step, one of the things that we were required to do was to highlight the device red if there were actually, in fact, any configuration changes. So for that, we did the add logic and added the intent data view, which we did define with the device highlight feature to be highlighted in red if the OSPF configuration changed in any format or shape. Now, NetBrain knows that it's gonna only highlight the device if and only if the configuration changes, because it's the intent data view right here. It's tied to the conditional for the configuration change. Moving forward, we go to the show IP OSPF neighbor command. In following the exact same logic for the table that we parsed, we had two actions that we needed to perform here. The first one was to verify if there were any neighbor changes, which we use the exact same technique we use for the configuration. We loop through the OSPF neighbors table, and then we look into the status of the neighbors for each and every one of them. If at any point in time the current value does not match the baseline, then we want to get notified. And if that's not the case, we want to be told that everything is just fine. We always encourage you to put the green message here because if nothing is wrong, you're just going to have no output, and sometimes that's just a little awkward. Then last but not least, we were required to also go ahead and map each and every one of the neighbors that were found product of the show IP OSPF command output. So for that, what we did is, for the exact same command output, loop again through the table once more after verifying the neighbor status. Go ahead and loop through the table again, and for every neighbor that it's actually printed on this table, I want you to be able to map it and put it into the map, including this as a neighbor device for this device, which is the one that I'm executing the intent on, as a layer 3 neighbor topology, because again, OSPF, it's a layer 3 protocol. Show IP route summary for the route count. Again, we parse the output of the show IP route summary command, and we look into the OSPF route summaries. We capture this in the format of a single variable because we have only one OSPF instance right here. Remember, I know that I said this, but in order to remind it, we I encourage you, if you have more than one OSPF area or more than one OSPF process, to use a paragraph parser instead, so you can capture each and every one of the iterations for the same patterns. And for the diagnosis, we're validating if there are any changes between the current value and the last time that this executed for OSPF routes. In this particular case, if the networks or the subnets change it, then we want to get notified, and if there are no changes, we want to be told that everything's fine. Now, if you remember from the objectives, we had to map all this and display it underneath the target device in the form of a table that's clickable, that we can access the exact same information that we're seeing right here, but mapped in a tabulated format. So we decided to put that on a second diagnosis here. For every time that a device just shows up in the map, that's just simply a condition, we want to be able to see those tables that we mentioned, the OSPF neighbor tables, and at the same time, the OSPF configuration, as well as the device node that we wanted to display the OSPF configuration for that device globally as well. So you can see the three things were added here, and this is going to be in addition to the device highlighting that we set up on the previous diagnosis. All of that is going to just act together as a one single intent data view. Last but not least, we created the seed automation right here, and once this is ready and we're happy with the diagnosis, what we need to do is replicate it to the rest of the network for every other OSPF speaker router to get the exact same level of verification. So we're going to go into the intent replication wizard, and because of the selected output for us in this particular case is going to be auto intent, because we want to consume this information in map, we're going to leave that option selected and click next. Because we did this from the intent itself, we don't need to browse for that intent. NetBrain understands that this is the actual intent that you want to replicate. And the only thing that is left for us to do here is to say, okay, qualify this intent to be replicable for every other device that has OSPF enabled in the domain. That's all we have to do. Click next. The next step is to install this as an intent template. So we're going to say, NetBrain, in order for you to copy this intent to every other device that speaks OSPF, templaticize this intent, install it under the presenter material folder inside of the automation center that I'm going to show you in a few minutes, and then go ahead and click the code for NetBrain to copy from the seed device that we created this intent for into every other qualifiable device for every command, every design, every diagnosis that we define on the seed intent. Last but not least, we need to enable this auto intent to show in the map, like we did here for the auto intent when we executed this for the showcase, and put it in the folder presenter material. This is just a folder that categorizes auto intents inside of the library, and then the actual profile that you will use if you want to filter these auto intents within the map. You're going to select it right here, either create a new one or use one of the existing. We're going to click finish, and this whole process is going to be completed. NetBrain is going to copy the exact intent that we created to every other OSPF speaker device. And then if you remember from the actual tasks and requirements, we were also required to make sure that NetBrain recurrently decodes the same intent, meaning that it replicates the same intent every day at 6 p.m. at the same time that it updates the baseline values. And when we do this is on the intent-based automation center, the IBA center. We navigate there, and we're going to find that folder that we defined, which is presenter material. You can see our automation has been installed there properly. And then we changed from one-time decode to a recurrent decode option to happen every time at 6 p.m., every day at 6 p.m. Eastern. At the same time that we are redecoding, we are also updating the intent baseline at the exact same time. The reason why this is useful is because if you add new OSPF devices or new OSPF devices come up in your domain, NetBrain is going to be incorporating those devices and adding them a copy of that intent to each and every one of those new devices that were added or incorporated into your domain for them to be covered by the automation as well. I hope this has been informative. I would like to thank you for spending time with us today for Challenge 1. I will send this back to Jeff, over the fence, Jeff, to you for more automation showcases. Thank you.
Thanks, Christian. I'm sure there are many folks out there watching right now preparing to implement that solution right away. For Challenge 2, Auto Diagnosis, we asked you to consider the situation that every network engineer has faced some version of during their career when a colleague reports that the network is slow. In this instance, we have multiple people reporting problems with one of the video servers on the network and experiencing intermittent video quality issues. Even worse, initial indications are pointing to this being a transient issue, which is going to make identifying the source a bit problematic. To get started with the hackathon solution, I'm going to break down the automation design into 3 logical segments. First, we're going to establish the foundation of our automation by creating a map of the network segment where the issue was reported. Perform a quick health check of the devices, and then open an incident within the NetBrain platform for increased visibility and collaboration potential. Second, I'm going to create a custom intent-based automation for the devices and traffic flow that I want to troubleshoot, pinging the source and destination devices looking for failures and latency, monitoring for any unexpected routing changes, and looking for interface errors and then QoS drops on the routers. And finally, I need to schedule the automation to execute on its own, create an automation dashboard for continuous monitoring, and then configure email alerts to generate from the dashboard so that if the issue reoccurs, I'll get notified right away. So what's required to build our network path map? Well, first, we need to ensure that we have a source and destination IP address within the impacted area of the network. Once the AB traffic flow is mapped, an initial assessment of the device health can be completed with the overall health data view template. Finally, we'll create an incident within the NetBrain platform to open up that collaboration possibility with the incident portal feature. So let's jump right into the product and get started. First, let me create the network path map using the challenge IP of 10.20.10.10 as the source to our video server at 10.30.11.100. With the path map created, the next step will be to apply the overall health data view template. This will allow me to do a quick assessment of the CPU, memory, and uptime of the devices on my NetBrain map. Well, it looks like all of my devices have a reported uptime of at least 2 days or more, and all the CPU and memory looks okay on each device. And now, in order to create the incident portal, I need to first save my map. With my network path map saved, I'll finish off this segment of the automation challenge by creating a new incident portal. I'll click the new incident button in the upper right corner. Then I'll provide a name for my incident, set my save point, and enter a first comment for anybody that will eventually join the portal. And then the last step will be to turn on the incident portal itself by enabling the portal feature so that anyone can log in and check troubleshooting status. I'll also apply an access code so that this particular instance is not publicly available. The last thing I need to do is to check to make sure that my portal and password works. And now here in the incident portal, we can see the latest state of all of the overall health data view. We can see the message that I submitted, and I'm all set with this part of the challenge. Now that the network path map has been established, this is where the fun begins, building the no-code automation. The automation design for this solution will be focused around 4 CLI commands and the diagnosis logic associated with it to isolate and potentially establish the root cause of the issue. We're going to create an automation that has each device in the path ping both the source and destination IP address, looking for ping failures and to measure the average round trip time on that command. Next, we're going to catch any unexpected changes in traffic routing using the show IP route command. We're going to look for interface errors with the show interface command on each outbound and inbound interface. And lastly, we'll perform QoS checks on the routers looking for drops. With the commands in hand, let's jump back into the product to build out and demo the final solution. Back at my network path map, I'm going to start the process of constructing my no-code intent-based automation by using our all-new quick intent workflow for rapid automation prototyping. In the input command field, I'll type my command that I want to run across all my devices, and then click Retrieve to pull live results from all of those mapped devices so that I can begin construction of the automation. With the raw CLI command response from the devices in hand, I now need to turn a few important data fields from that response into usable variables for the diagnosis. And to do that, I need to build a parser. In the visual parser dialog, I'm going to use a variable parser because the ping command doesn't respond in an organized column and row fashion like you would see in a table, and doesn't have repeating blocks of text with a predictable first line and then variable data underneath where a paragraph parser may be used, like say a show interface command. First, I'll name my parser. And then I'll grab my first line of data that I'm looking to parse. I'll turn the IP address of the destination into a variable. And then I'll grab my second line of information where I need to grab my success rate. The count. And my min, my average, and my max response times. With my ping command properly parsed, I now get to click the Add Intent button to begin to develop my diagnosis logic. And my first piece of diagnosis logic is to ping check the destination IP, looking at my success rate. So I want to check to see if my success rate is less than 100%. And if it is, then we've encountered a failure scenario. So in my diagnosis message that will display on the NetBrain map, I'll color it red. I'll indicate that it's a fail, just to be super clear. And then I'll say ping success rate 2. Now when I type the $, NetBrain then pops up a dialog box that allows me to insert any of the variable data that I've collected from the command response into my diagnosis message that will display on the map. So I'll select my destination IP. I'll then create my else condition, so basically indicating that I have created a successful ping response. So I'll color that green. And then say ping to destination IP is successful. And I've finished my first piece of diagnosis logic against my ping command. I'll extend this intent even further by adding an additional diagnosis off of this same ping command to check the average response time. So I'll click New Diagnosis. and it's completely cleared that and has provided me a workspace to build a new diagnosis. For this, we'll check the RTT average. And for this, we'll probably use what we want to use as a threshold. So we'll say if the average is greater than or equal to 10 milliseconds, then that's a hard failure. And what we'd like to do is set a warning. So we'll use the else if condition and say that if the average is less than 10, but also greater than or equal to 5, we're going to set up a warning. And then anything else is considered a success. Now that I've successfully created my diagnosis logic and partially completed my intent prototype, these two diagnoses can be very quickly and easy copied to all the other devices on my map that have the same command output. I'm going to click the drop down here next to the ping command and click duplicate to other devices. I'll select all the other map devices. And NetBrain quickly duplicates all of my diagnosis logic. So we have the ping check and the check for the average response time across all devices that are available on the map. Now that I've duplicated all of this, it's time to test the active intent prototype and see this in action. So I'll click the Create button, and then I'll click Run. If I hide this, what we've seen is in just a few minutes, we've been able to build a piece of automation on one device and then quickly replicate it and test it across all other devices that are available on the NetBrain map. Now, with the foundations of the no-code automation developed, you're probably asking, well, what does the finished product look like before we save it? Well, we've already constructed one of the two ping command challenges, so let's take a look at the show IP route parser and logic. First, let's take a look at the parser. For this simple variable parser, we grabbed the next hop IP address and was able to safely ignore everything else in the command response. For the diagnosis logic, we used a very simple current versus baseline comparison to check to see if the next hop IP address changes at any point during automated execution. Now let's consider the show interface parser and logic. To properly extract these variables, we have a couple options, but I chose to use a paragraph parser. Here we're able to identify which line in the command response would repeat and set that as the ID line pattern. And in this circumstance, it's the ID where we indicate what the Ethernet interface is, along with its status. Next, we grab two portions of lines within the body of the command response to parse out input errors, CRC errors, and output errors. And for the show interface command, we created two pieces of diagnosis logic. First, output errors. In the output error scenario, we used a current versus last comparison so that we can properly capture an increase in the errors. Had we compared with the current with the baseline, then even a single error would ensure that this particular diagnosis, along with the check for input errors, would always fail when compared to its original baseline. And for input errors, it's the exact same thing, current versus baseline with the appropriate diagnosis message. Now last, let's take a look at the show policy map logic we authored for our two routers. Here is a great example when building a parser where it's clear that we want to use paragraph. In this command response, we have a clear repeating primary line, class map with the policy, and variable data tucked underneath it. We parsed out the class map name and then grabbed the line segment that contains the QoS drops to complete the parser. In our diagnosis logic, we only look at the video QoS policy and compare the current value of QoS drop with the last execution to complete our diagnosis. With our commands executed and properly parsed, the diagnosis logic in place, and the automation prototype tested, the last thing we need to do to complete this portion of the automation challenge is to save this as a map intent. First, we need to save the map. Then we come back to the quick intent workflow pane and save to a map intent. And this completes the second segment of our automation challenge. With the custom no-code automation prototype fully constructed and the map intent created, the last thing required for this challenge is to schedule it for automated execution. Quickly construct a shareable dashboard for ongoing network intent execution monitoring, and finally, enable email alerting from within the dashboard. All of this is accomplished with only a few mouse clicks per task, so let's check it out. With the map intent now fully built, executed, and saved, it's time to set the intent automation to execute on its own using the Schedule Run feature, which is accessible from the hamburger menu on the map intent pane. For the purposes of this challenge, we'll define our execution type as continually, which means we're going to repeat this every 10 minutes, and we're going to run it for a full calendar week. Now in the background, NetBrain has created a scheduled task that's visible in the domain management interface. It's automatically executing all of the automation defined in this map intent. What we can do to confirm this is to go back to the hamburger menu and then click refresh. And now we have a new little note right here that indicates that this particular map intent is scheduled and is running every 10 minutes for that full calendar week. With the automation running, the next step is to construct an automation dashboard for ongoing monitoring of the execution. The dashboard wizard can be launched from the same map intent pane. I'll name the dashboard and then set a save location for it. Next, we want to confirm that the dashboard will be constructed from the output of our map intent. And in this case, and this part of the challenge, since we launched the wizard from the map intent pane, NetBrain has already loaded the correct intent for us. We can leave the date time range as is, since we're looking to look across 7 days worth of data as per the challenge. With the dashboard built, there are three primary areas of monitoring: the overall execution summary, device details, and a detailed date-time timeline showing the execution points. As part of the timeline view, we also get the top 5 intent alerts, which can help provide immediate visibility when a deviation is detected. Everything in here in the dashboard also allows for a double click in to review execution details. Next, we'll enable email alerting for when an intent error is detected. So we'll edit the dashboard, turn on alert notification. I'll send that email alert to me. And in only a few mouse clicks, I'll now receive an email alert anytime my intent-based automation that's part of this dashboard generates an error. Now, the last thing we need to do as part of this automation challenge is to share a link to this dashboard into the incident portal. So in the Share Dashboard dialog, I'm going to copy a link to the dashboard to my clipboard, jump back into my path map, open up the incident, and then share a link to that dashboard so that it's visible to everyone. And with that, we have our completed second automation challenge, auto diagnosis. I'm going to pass the presenting duties off to Rami, who's going to walk us through our third automation challenge, network assessment.
All right. Thank you, Jeff. I'm sure everyone on the call enjoyed your solution. Without further ado, let's dive into our third challenge for today, network assessment. Depending on task on hand, you may need to perform a layer 2 or a layer 3 assessment. In this challenge, we're going to tackle layer 2. There are many problems could occur on a layer 2, from MAC addressing errors, duplex errors, collisions, layer 2 loop, or spanning tree problem. You have been tasked to assess STB instability for your entire network or for a specific data center. In order to accomplish this use case, there are three major steps. First, we need to build the automation assets. Second, we need to replicate that automation assets across a group of devices. Last, we need to perform a continuous assessment. So let's talk a little bit more about the building piece. So we need to create a network intent that could assess if the root bridge is unstable under each VLAN. Then we need to assess if the root port is unstable under each VLAN. Lastly, we need to assess if the spanning tree interface status has changed under each VLAN. Once we build the network intent with its logic for one specific device, then we need to create a device group that includes all of our Cisco IOS switches to replicate that logic across these devices. Last, we need to execute the assessment one time and export the diagnosis into a CSV file that could be shared with other team members. Lastly, we need to execute the assessment continuously and monitor the output. For this task, we have three steps. First, we need to schedule the execution to run on an hourly basis for 1 week. Then, we need to build a dashboard to view all Cisco IOS switches execution results for all the assessment. Last, we need to configure the dashboard to send email to yourself if alerts are found and document these issues. Without further ado, let's dive into NetBrain platform and start building the network intent. First, we need to drag an IOS switch into an empty map. Then we need to define our diagnosis. To do that, I'm going to go ahead and click on intent and create a new quick intent. First, we need to type in the show command. So I will go ahead and type in show spanning tree to get our output. Once we're able to see the command's output, we're going to go ahead and build a new parser. The first two requirements, we need to parse out the MAC address and the port number under each VLAN. In order to do that, we need to use a paragraph parser. Before we parse the requested information, as best practice, always try to give your parser a proper name. this case, we're going to call this parser root Mac port. Now we need to parse out each VLAN. We go ahead and remove the VLAN ID, click on $VLAN ID. Next, we need to parse out the MAC address. So I'm going to call this, type in address, $MAC address, similar to port, $port number. Now I was able to parse out each VLAN, MAC address, and port number. The last information that we need to parse basically is the interface status under each VLAN. As you can see, this looks like a table. Therefore, we're going to use a table parser. We're going to add a new table. As best practice, always give your table a proper name. So we're going to call this port status. Now, in order to parse out the each interface status under the VLAN, we're going to go ahead and use a function called parent to bring out the first table that we've created. Then we're going to highlight on the table header and add a semicolon in order to separate some of the table columns. Once we've done that, we click on the plus sign to parse out the interface along with the status. So as you can see, right now, we have parsed the MAC address, port number, and interface and its status under each VLAN ID. Next, we need to go ahead and create our diagnosis. Right here, we can call this diagnosis root MAC port. We define the VLAN ID, looping the first table that we've created, root MAC port. We choose the VLAN ID. In this section, we want to make sure that we any changes on both MAC and port, we want to be notified. So the logic will be if the MAC address in the current data set does not equal our MAC address on the last data set, then I'll be requiring an alert. Similar thing we'll do for the port number, and we change the baseline to last. Now, by default, the Boolean expression will have both conditions, A and B. We are going to change that to A or B. Now, once we've done with the diagnosis, we want to go ahead and define our diagnosis message. So I'm going to get an alert right here. So we're going to get an alert on this specific device if the root and MAC port change on VLAN. We can click on the $sign to print out each VLAN that has any problem. We're going to enable the message for both device and an intent status code. Next, we need to add an else logic to basically print out a success message. So in here, similar, we're going to print out the device name, and I want to have it for each VLAN. So $sign for each VLAN. Now let's go ahead and create a temporary intent to check this logic. I'm going to go ahead and run it. So as you can see, I've got an alert saying that either MAC or port has changed on each of my VLANs. The reason why we're getting this error, because we're comparing current to last, and we don't have any data in the last, and that's why giving us this error. Once we run this intent again, we'll be able to see a success message on both of these VLANs. Now, second, we're going to go ahead and define a diagnosis for the interface status. So we can call this check STP port status. And we loop in the table for the port status, choosing the VLAN ID along with the interface. Now, we only need one diagnosis in here. So basically, the status of the interface, it's not equal to the status of the interface between current and last. Next, we need to define our diagnosis message. Here, we have an alert this device STP port has changed on specific VLAN, so I can add a $sign and add the VLAN ID here, right here, and enable this for a device and an intent code. Now we want to make sure we get our success notification as well, and we can do the similar thing, adding the VLAN ID here, enable that for device and intent status code. Let's go ahead now and recreate and run this intent. So as you can see, now I have 4 alerts, 2 of them for the MAC and port, and the remaining 2 for the status change. Similar to the previous reason, because we're comparing current and last, if we run it again, we should have a success errors or success notification on each VLAN for this specific switch. Now next, we need to go ahead and save this map, and then go ahead and save our to map intent. Next step will be to create a device group to replicate this logic across those groups. All right, next, we need to create a device group that contains all of our iOS switches. In order to do that, we click on the plus sign, create a new device group. I call this iOS switch. From the dynamic search criteria, we're going to go ahead and choose or define our criteria for device type that only contains an iOS switch. I'm going to go ahead and share this under Hackathon folder. As you can see from here, I've created a new device group that contains 20 switches in this environment. Next, I'm going to use the intent replication wizard to replicate this logic across those 20 devices. In order to do that, we click on an intent. From this menu, intent replication wizard, we choose an ADT. We'll click on next. And here we need to choose the device group that we've just created. I'll click on iOS switch. Click on next. We install and decode. Next option, we're going to create a new ADT via the device group that we've just created as well. We go to Hackathon, iOS switch, we choose for this group. As best practice, always give this proper name. So we're going to call this SDP check. Click on save. There are 2 criteria we need to pay attention to. First, we need to check the device so that it will match every device from the ADT into our device group. I'm going to give this proper name, SDP check. We need to have the intent status code to know if there's an error or it's a success. So we're going to go ahead and check intent status code. We'll click on apply, rebuild, and open ADT. So as you can see from here, we've had the network intent that's been added into every device, along with the intent status code. If you don't see the status code in here, what you need to do basically is run intent once, and then rebuild table. You'll be able to see the status code. Once we have the information, the last thing we need to do basically is to export this information into a CSV file. So from the intent menu right here, export diagnosis result to CSV file. You can choose what kind of errors or execution times or any other options that you need to be added into your CSV file, and click on export. As you can see from here, I have the list of 20 devices along with the diagnosis message for each VLAN in terms of the MAC or port changes, along with the port status. All right, so lastly, we need to perform a continuous assessment to run at the back end on an hourly basis for the next week. In order to do that, we can click on the menu next to the SDP check network intent that we've created and run intent via timer. And here we need to set up our own timer. So I'm going to call this timer layer 2 network assessment for SDP. We're going to run this on an hourly base, and we're going to have an end date for the next week. Now, once we've scheduled the network assessment to run at the backend on an hourly basis, what we need to do next, we need to visualize all these messages, either success or alert, into a dashboard for a better visibility. In order to do that, we can click on the plus sign right here, create new intent dashboard. We call this, again, proper name, layer 2 network assessment for SDP. We'll click on next. We need this to build from an automation data table, and we choose the automation data table that we created as our data source. We can leave this as 7 days. We'll click on create. The moment all the data that's all for the network intent that's been executed previously will populate it on the dashboard. As you can see from here, we'll have the summary information related to the intent, along with the device information and the intent result history. So any errors that occur, you can have an option to see exactly on which hour, basically, these errors occurred. And then in here, you see the amount of devices that this network intent or assessment has been run on. Next, what we want to do, we want to set up an email alert in case we hit any errors. In order to do that, we click on the edit alert notification. We enable this option, and then you can either have an email address of a group or a particular user. So I'm going to go ahead, click on my own email address right here, and click on OK. This way, any alert that comes from these executions will be sent out directly to me, and I'll deal with it in a proper manner. So with that being said, back to your question for our final challenge for today.
Well, thank you, Rami. Now, let's delve into our final challenge for the day. Challenge 4, Safe Change Solutions Walkthrough. The objective of this challenge is to empower engineers with the capability to verify and validate the operational and design status of networks and applications before and after implementing a network change task. As we explore the platform once more shortly, we aim to demonstrate to engineers how proper checks and assurance steps can be automated to ensure the safe implementation of network changes. We will automatically validate intentional and non-intentional impacts on targeted and non-targeted infrastructure before and after any change or implementation. This involves ensuring that after a specific change task, the introduced configurations adhere to standards and newly advertised routes do not impact existing applications, among other configurations. We will utilize data such as pin and traceroute results, golden configuration, and design rules to assess whether the change was applied and if there is any residual impact or regression in the network or supported applications. The changes for this example include adding a rule to the firewalls to deny the desired traffic flow, as we can appreciate here on the picture, and removing and adding prefix list entries on the two highlighted routers respectively to prevent routing towards the reference prefixes. You can see router 1 and router 1. Our pre-change initial step is to map the change blast area. In other words, the traffic flow footprint that we need to disrupt. You can see from network 172.16.2.10 towards 10.10.10.10. Next, we will create our pre- and post checks in the form of network intents to conduct the necessary validations, adhering to the challenge task guidelines, and verifying whether the change has been introduced or not. Last but not least, after implementing the change, we will leverage various automated checks to validate any impact or regression introduced to the network or supported applications. This will include critical application checks, design rule checks, golden rule checks, and critical servers connectivity and reachability tests. This means we're going to be able to validate if any other applications running in our network could be impacted by the change that we just introduced to the network or not. Likewise, if the configuration that has been introduced into the network devices is compliant or not with our configuration standards. And last but not least, we will have a list of well-known servers that are critical to our company, and we need to make sure that those are not affected by the changes that we are introducing. That being said, let's go ahead and jump into the challenge task solution demonstration. All right, back in the platform for the last time of the day, for the last challenge demonstration. We're going to do a quick overview of the automation goals that we are requested to complete. And for that, we are requested to propose a change over the weekend to disable an unsafe connectivity between an enterprise and a production domain. We are tasked as network engineers to build the proper automation to verify the proposed design, check whether there is impact after or regression after the change that we are implementing, and then automate the mandatory checks that we will implement for pretty much every other change as pre and post verifications. Now, the very first step that we are required to do is to create a map containing the traffic flow footprint between the reference source and destination IPs. Now, in order to accomplish this, all you have to do is go to the top of the desktop area, introduce on the path calculation bar your source IP address of 172.16.2.10 and the destination IP address of 10.10.10.10. In order to make sure that you're capturing the latest and greatest path, make sure that you click the gear button here and you have the live option selected to make sure that you capture the latest and greatest path. For the sake of time, I'm not going to be doing this, and I already have a pre-built map that already contains the reference footprint, so I'm going to go ahead and open it for the sake of the demonstration only. And then the very first step in terms of automation that we're requested to do is to create a network intent that verifies whether the change has been applied or not. In order to look for that, what we're going to do is we're going to go into intent, click on quick intent, and use the data collection features that we have for our parsing, such as running CLI command or configuration. In this particular case, we are asked to verify if there are configuration changes, whether we're talking about both of the firewalls and both of the routers. So what we're going to do is we're going to select both of the firewalls in both of the reference routers in question, and we're going to hit retrieve. What this is going to allow us to do is to execute without the need of any diagnosis or parsing. Is going to allow us to execute the data collection for configuration before the change and after the change, and use the built-in comparison feature in order to verify if there are any changes that were applied to the devices. In order to do that, all we have to do is use the comparison button right here. So we're going to add this to an intent. We are going to do this as well for the firewall. We're going to do this for the other firewall, and we're going to do this for the other router. By clicking create, then we can run this before and then once again after the change, and make sure that, as we mentioned before, the comparison checks out or not. We'll give it a couple minutes for that, for this to show. And then you can see here by every single one of these changes and diagnoses are going to have the comparison feature enabled into it. So we can go ahead and verify if this has been checked, changed, removed, or not. In this particular case, there's no change highlighted because this is the first time that we're executing this right here. Now I'm going to navigate for the next section in order to start creating the diagnosis that we're requested to do. I'm going to shift over to our map intent, which is basically the footprint that we created saved into the file system, and then properly added as a network intent, map intent. So this, in order, the steps required to get a map intent saved are: first, save the map that we're working on, and then out of the temporary intent that you have created, save it to map intent. It's important to note that if you don't have the map saved, this option is going to give you an error message. So make sure that you save your map first in order to save this map intent as map intent. Once that's completed, you should see the legend up here at the top of the map, indicating that the actual network intent that we just created has been successfully embedded as a map intent. What this is going to allow us to do is, further down the road, like I did in this case, head into the map intent tab, and open up the intent has been associated with this map and run it over and over for a particular or specific task, like in this case. Next, what I'm going to do is I'm going to show you how we resolve the next set of challenges that we're requested to do in terms of automation, which are requiring us to look into the routing changes, if any. And for that, what we're going to do is we're going to create a network intent that doesn't look just on the configuration, but also into the routing tables, whether, again, this is a router or a firewall. In the case of the firewalls, we're going to execute the short routing destination command. We're going to parse the results. And if we're talking about a Cisco router, obviously the show IP route command towards a specific destination. Out of these commands, we're going to parse the exact same type of information. We're going to be parsing and making sure that the next hop, if the next hop changed, or if the next hop did not change. Now, the objectives of this change are to actually disrupt this traffic flow. So if the next hop, when we execute the change, like in this particular case, when we execute the intent, when we execute the network intent, if the network intent is telling us that the next hop is equal, then the flow wasn't disrupted because the route still exists, and then the change needs to be needs to be applied. When we do detect a next hop change, then we will know that the change has been successfully implemented. We repeat the process for the router. So if we navigate back to the router, we can see the exact same definition. We're looking into the next hop, and when we navigate to the diagnosis, we're going to see that if the next hop did not change, the change was not applied. And if the next hop changes, then the change has been successfully applied. Now, keep in mind that this specific check, it's built with the purposes of covering the verifications for this specific change management task. Different change management tasks will have to, obviously, will require creating a different part of a different type of automation in order to cover those as well. Just a quick clarification there. Next, what we're required to do is we are requested to start creating a set of verifications that encompasses making sure that once the change is applied, that there is no impact to any of the other applications or traffic flows in the network, or that NetBrain knows at least, that the changes in the new configuration that we input into our devices is still compliant with the configuration standards that we have as a company, and that we're still in compliance of the design rules of how the network is supposed to work overall. So in order to do that, what we're going to do is we're going to navigate to the auto intent, and this is what the guide is asking us to do. Navigate to the anti-drift profile on auto intent, and there we will find both of the auto intents that we need to apply to the entire traffic footprint. We're going to do the design rule check first. To that, we're going to click and select every device on the path. We're going to click create. And what we're going to do is we can either execute this from here to verify this, but in order to save these results, we're going to save them as a common intent. Similarly, once completed, we're going to deselect everything and repeat the process for the golden configuration checks. Making sure that the golden configuration and the configuration standards are respected, we're going to select every device in the path to be executed under the same auto intent. We're going to recreate. We can either run this or and then ultimately save it as a common intent. Now I'm not going to do this because I already did this. As you can see here, I already have my design rule checked, save, my loading configuration check, save. The next step is then to do the exact same thing and repeat the process, but just under a different profile in order to verify the critical applications. So we're going to change the profile once again, deselecting everything first to make sure that this does not get included on the next verification that we're going to do. I'm going to hover over impact application analysis, and I'm going to repeat the process for every device that is part of this footprint. I'm going to recreate this once again, execute, and then save as a common intent. We are not going to do that now because, again, as I mentioned before, we already have the save as critical applications. You can see this intent has been successfully executed once it has been saved as common intent. So all you have to do is place it on the folder of your choice, and then just come here and run it, or execute it before saving it, and then saving it in order to get the results. And then you can see that the change has been already applied, and then you can see that my IP next hop is changing as an indication that the change has been successfully completed and applied. It is exactly what we were looking for. But we're making sure that any other device is not reporting any other issues in terms of change of routing. This means that at least any other application is not being impacted by routing changes. That's the exact goal of the automation that we're running here right now. Last but not least, in order to create the automation that is required for us to complete this challenge, what we're going to do is we're going to go into the automation data tables as we are requested by the task challenges, that we include verifications for critical servers that are listed inside of a CSV file that we were provided with. In order to do that, what we're going to do is we're going to navigate into automation data tables. And inside of the folder of your choice, you will create a new table, which source is going to be the CSV file that we are going to import from the file system right here under CSVs. You can see that the critical checks contains the list of IP addresses that we need to target. And in order to do that, one of the things that we have to do is point to that CSV. We do that by selecting the CSV, import from a local file system. This means looking inside the network itself. You point to that CSV file, critical checks, and then you import that into this table right here. Once you have successfully imported that, all you have to do is drag and drop the columns as you find it on the very CSV file in order to import this data and make it automation data table available. And once completed, make sure that you select the device and the target IP as table keys. Once you save and build, the table should be ready, and all you should see are columns all the way to test results, and then the rest is going to be what we're going to be adding as part of the actual challenge. So in order to do that, we're going to go back to the map, and we're going to go back to quick intent once again. And by introducing CLI commands, we are going to select, say, one of the routers, and we're going to say ping to 10.10.10.10. Actually, let's take one of the IPs from the list, making sure that we are indeed reaching out to that destination. And you can see that we are doing that. So what we're going to do is we're going to add this to the intent, and then we're going to parse it correctly and properly. Now, I'm not going to demonstrate the entire process of how to create this, but you can always go back to the environment where we did create it, this intent. I'm going to show you right now. We already have this built. Then by editing this, and then we're going to do the exact same process for traceroute as we are requested on the challenge. So you can see that this is the command that we're running, ping to one of the destinations, and we are parsing the data, the destination IP out of the command. We are checking the average round trip time that the ping provides and the success rate in order to perform our verification. For diagnosis purposes, what we're doing is we're verifying if the success rate does not equal to the baseline, meaning if this was 100%, then everything's working fine. If it's less than 100% or different in any form or shape, we are going to be printing what the value was 100% and what the value is right now, and does it change. We're going to be repeating the exact same process for the trace route. There we go. And then let me show you how this works for the trace route as well. So we're going to be introducing the trace route command. How this command parses out is one big huge table that we're going to analyze as a whole in order to see if any of these changes at one point in time, whether an index or sequence number changes or a next hop changes from the original trace route. We want to get notified, and we're going to reflect that into the diagnosis as such. You can see we're comparing the entire table produced by the trace route between the current value and the baseline. And we are notifying the users that there is change, if so, to get the proper notification. All right. One of the things that we have to keep in mind is that here we're executing a command with a fixed IP address, and what we actually need to verify is a set of IPs that are part of this list right here. So I want to make sure that from each and every one of these devices, we can still reach out to the destinations that we have listed here. So how do we get from a fixed command with a fixed IP to actually have a dynamic change of IP address in order to feed this command with a proper IP? We're going to walk through that really fast right now. So we're going to head down to the actual intent. We have the ping and the trace route. And as opposed to how we did on the challenge number 1, where we were replicating this using the auto intent feature, we're going to do something similar. We're going to go to the intent replication wizard, but instead of doing replicate via auto intent, we're going to replicate into an automation data table. This is going to give us a result that you're seeing here of the ping and trace route towards a specific IP. It's going to be automation data tables have the capability to replicate the intents as well. So there is no need for us to install this, as you're going to see in a few seconds. So we're going to select the second option and we're going to click next. Again, one of the advantages of doing this from the actual intent is that you don't have to browse for that intent, and you can quickly move forward as you need it. And then for the definition here of the qualification, we are going to target this for Cisco routers and Cisco switches. We're going to click OK. And then here is the exact point in time where we are going to do that variable designation in order for us to be dynamically assigning these values from that table that we just showed. So we're going to go ahead and click on this row right here. And what this opens is a dialog box at the bottom where we are going to say we don't want to use a fixed value. We want to use a variable value that we're going to define. This is just an arbitrary name that we are going to define. And once we do that, in order to make sure that we are providing with the right values in order to feed this destination IP here, is to go ahead and select the values from the data table that we just created. So what we do is we navigate to the table that we created and we select the target IP address as we have it listed here. You can see target IP. And we target that column right there. And we select the proper variable, click OK, and do the same thing with the trace route. Change this to whatever variable name. It could be the same. It's still going to be a different value. This is again just an arbitrary name that is unique for each command. So don't be afraid if you duplicate the value of the variable name. In this particular case, I used 2 different ones, target IP and destination IP. But if you decide to do destination IP on both, that's still unique for each of the commands. Just make sure you're targeting the correct IP address from the table as we showed before, and you will be fine. You can keep moving forward to the next. There's no need to install this like we did on challenge 1, because again, the automation data tables, as soon as you replicate from Wizard or you add a network intent into a table, it automatically replicates because it understands that you want to copy this intent for whatever devices you have listed on that table. So there's no need for us to pre-code this. Now, the next thing that we're going to do is we're going to select the table that we already created, which is I'm not going to actually do it, but I'm going to show you how. You go into the critical servers right here, and then you will see that we already have this created here. You will populate a new column that you will name trace and ping. In this particular case, because we already have it created, we need to select the update the existing column in order to showcase what we did. And make sure that here, once again, you are pointing to the right values within the table, and you should be all set. Now, make sure that you select device in order to replicate. So what this reads right here is for every device that is listed inside of your automation data table, create a replica of the original intent that we created for this particular switch. And make sure that you target every single IP address on the ADT as a target IP in order to test ping and trace routes alike. You have the opportunity here to rename the column name for that replicated intent as it's going to show on the table. And the same thing for the status code, because we want to see what's going on once the intents are executed. Once we're going to do that, we're going to apply a quick apply. You're going to have here a button that says rebuild ADT, so go ahead and click it. And then you can go ahead and open ADT in order to navigate to this screen that you have right here. Last but not least, one of the things that is left to be done, as I'm going to click finish, is to create a dashboard as an output to visualize everything that we have been done in terms of automation and its results. So what we're going to do is we're going to click on let's see here, plus sign, new intent dashboard. We're going to put a name, and then we're going to save it inside of the folder of your choice. And then as a data source, we're going to put this just in terms of, just for the sake of moving forward. For data source, instead of a specified intent, you have two options. You can do either specified intent or from automation data table. So we're going to do specified intents for the first three in order to showcase the proper critical applications, design rule, and volume configuration rules. And then we're going to add a fourth group for this particular dashboard that is going to showcase the critical application servers, and we're going to be previewing. Now let me open the one that I already have created for this. I'm going to navigate into the dashboard manager. I am going to go into material, and I'm going to open the dashboard that I already created. So you can see that I have renamed all of them here, the four groups that I mentioned before. We're going to do this with a change validation, which is basically the first intent that we created, that is the map intent. Then the three common intents that we saved. And then last but not least, the automation data table. Now, in order to do this, we're going to go to edit. We're going to click on manage input. And here, by adding an intent group, is how you want to add each and every one of these. Every time that you add an intent group, it's going to ask you if you want to add a specific intent, or if you want to add from an automation data table. So you can see here that what we did is we added 4 specific intents, and then in the end, we added an automation data table. Once you're done with all this, what you should see is a dashboard containing all the 5 verifications that we have built and all the executions that took place until now, since the very beginning when you first built that automation. In order to refresh the data in case you have executed this further and you want to display the latest and greatest, you can go here at the top right of the page and click the small refresh button right here to refresh the latest and greatest of each and every one of the automation pieces that you included on this dashboard. And with that, you conclude the challenge demonstration for number 4, Safe Change. And that being said, we're going to send it for one last time to Jeff over the fence to you. Thank you so much for your time. I appreciate it, and have a great rest of your day.
And now, let's get to the moment you've all been waiting for, our November 2023 Automation Hackathon Awards Ceremony. I have the great pleasure in announcing our bronze, silver, and gold medal awards. As I mentioned before, this truly was a global event with the majority of our participants and submissions coming from the United States, Canada, England, France, Germany, India, and China. We here at NetBrain are truly impressed with both the response and the quality of the submissions. Before we officially crown our winners, let's quickly review the judging criteria applied to all submissions. All submissions were scored on a 100-point scale, looking for completeness of the submitted solution, accuracy to the design requirement, and overall quality of the implemented solution. And now, for our November 2023 hackathon, I am proud to announce our bronze medal winners. Harishandra Sabale, Abhishek Sharma, and Rakesh Mandava. Our silver medal winner, Pramod Alu, and finally, our November 2023 Automation Hackathon Gold Medal winners, Vamsi Kala, Venkata Vimula, and Yogesh Kodisana. Congratulations to everyone. All of our winners will be contacted directly with their awards after our webinar concludes. For those of you that did not win an award this hackathon, don't forget, all solution submissions and points awarded do accumulate for our bigger awards and prizes. We'll have our quarterly prize raffle, and once certain scoring thresholds are met, we'll be awarding the titles of Master of Automation and Grandmaster of Automation to those that demonstrate continued participation and success as part of future hackathons. Congratulations again to all of our winners. Now, maybe this award ceremony is the first time you've seen what's possible with automation done the NetBrain way, and now you really want to know more. Well, contact your NetBrain account executive, your customer success manager, or come check us out on YouTube. We have amazing video content that will help you optimize your NetBrain platform for automation readiness, showcase important automation concepts, and even get you started on the path of becoming an automation expert as well. If you're already building your own intent-based automation, there's always a chance you'll find yourself stuck. Don't forget to connect with us at our Ask an Expert automation hotline. Whether it's difficulty parsing a particular command response, building an automation data table, or you're just not clear how to make your automation available to the rest of your organization, our experts are ready to help. Well, here at NetBrain, we have a lot of new and exciting innovations in no-code automation coming your way in 2024. So please keep an eye out for our next hackathon announcement on our website, www.netbrain.com, our Exchange community, exchange.netbrain.com, and we may even send along a personal invite or two. So keep refreshing that inbox. Now, on behalf of my colleagues, Christian and Rami, and along with the entire NetBrain team, thank you all for watching. We look forward to seeing what amazing automation you can create in 2024, and we'll see you next time.